Hi friends, welcome to my YouTube channel. Friends, in this lecture we are going to discuss superposition theorem. The statement of superposition theorem is if a linear network has several independent sources, the net current or voltage across any branch can be obtained by adding the response of individual independent source across that branch. Okay, here you have to emphasize on this word linear. It is applicable to only linear networks and it is not applicable for power calculations. So these are the two important points related to this superposition theorem. So when in a network number of sources are given, suppose here it is given a voltage source and this is resistance, here is again a voltage source, suppose E, and suppose here it is a current source. Okay, and suppose we have to find the current in this resistance R. So we will find the current, first of all we will find the current in this resistance R due to this voltage source. Okay, so when we are finding the current in resistance R due to this voltage source, then we have to make all other voltage sources short circuit and all other current sources open circuit. After making this, we will find the current in this resistance R. Suppose current due to this voltage source is I1, okay, and current due to this E is I2, okay, and suppose current through this current source is I3. So total current across resistance R when all these three sources act simultaneous will be equals to I1 plus I2 plus I3. Okay, here you can see that the statement says that if a linear network has several independent sources. Now here I want to tell you this superposition theorem can also be applied to circuit having dependent sources, but there you have to take caution. You have to keep the dependent voltage source intact. Okay, so when I solve the question I will clear all these things and you will get better understanding of this concept when you solve the numerical related to superposition theorem. But at present you have to remember that superposition theorem states that if a linear network has several independent sources, the net current or voltage across any branch can be obtained by adding response of individual independent source across that branch. And superposition is applicable to linear networks and it is not applicable for power calculation. Okay, you must remember these two important points. So now we will solve a numerical based on superposition theorem. Now we are going to solve this circuit. In this circuit, this 3 ampere current source is given. This is 10 volt voltage source. This is dependent voltage source, that is 2ix, and this is current ix. Now we have to find the current ix. I will solve this problem with two methods. Okay, first I will solve this problem with superposition theorem. After that I will solve this problem with another method. So after watching this problem solution, you will be able to decide which method is easier. So first solve this by using superposition theorem. So what we do in superposition theorem? We take the voltage, all the sources one by one in the circuit, okay, and at last we add up the response of individual sources. So here we have to take care of one important point, that we will take only these two independent sources and we have to keep this dependent source intact. We have not to touch this source. Okay, we have to keep it intact. So how I do this? See, first I will take this 10 volt source, then I will find what is ix. Okay, so when I take this 10 volt source, I will make this 3 ampere current source open circuit. Okay, this is 2 ohm resistance and this is 1 ohm and I have to keep this dependent source. Okay, now apply KVL in this loop. What we get? 10 is equals to, this is ix1, 2ix1, this is 2, okay, 2ix1 plus ix1 into 1 plus 2ix. Okay, this is ix. So on solving this we get ix1 is equals to 2 ampere. Now take this 3 ampere current source. So while taking this current source we will short circuit this voltage source. So short circuit this voltage source, that is 2 ohm, 3 ampere, okay. Again I am keeping this dependent voltage source intact. Okay, now what is this ix2? So ix2 will be equals to 2ix2, that is apply KVL, plus what is current in this branch, that is equals to ix2 plus 3. Okay, this 3 ampere and this ix2 will add, so I will get ix2 plus 3. So ix2 plus 3 into this 1 ohm plus 2ix. Okay, that is equals to 0. So on solving this I will get ix2 is equals to 2 plus 3ix2 or 5ix2. Okay, that is equals to minus 3 by 5, so it will be equals to 0.6, minus 0.6. So ix1 is equals to 2 ampere and this is equals to minus 0.6. So what is current ix? Ix is equals to 2, that is ix1 plus minus 0.6. So what we get? We get 1.4 ampere. So this is first method to solve this problem. Now take another method to solve this problem. See, in this method what we have to do? Suppose this is 3 ampere, this is ix. Now what is current in this branch? That is equals to ix plus 3. Okay, now simply apply KVL in this loop. 10 is equals to 2ix plus ix plus 3 into 1 plus 2ix. Okay, so what we get? 10 minus 3, that is 7, is equals to 5ix. So we get ix is equals to 7 by 5, that is equals to 1.4 ampere. So I am getting the same answer. Now you can see how easily we can solve this problem by assessing the right method to solve a particular circuit. Here if you apply superposition theorem in this circuit, then it will be quite lengthy. But if you apply the right concept, simple KVL and KCL, then you will easily solve this problem in just 2 lines. So here you have to develop a right approach to handle a problem or to assess the right method to solve a circuit. If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.